Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 342. If you haven't solved a problem power of 2, I will give in description. Just go and solve it. Then you can approach this problem, right? Given an integer n, return true if it is a power of 4, otherwise return false. An integer n is a power of 4 if there exists an integer x such that n is equal to 4 power x. So they will give an integer n, and if that integer n can be represented by a power of 4 power any number, it is true, right? Else it is false. Okay, let us see the example. See here, n is equal to 16. So 16 can be written as 4 power 2. N is equal to say 64. 64 can be written as 4 power 3, right? N is equal to 1. This can be written as 4 power 0. N is equal to 4, which can be written as 4 power 1. Right? So these are the things we can say it is a power of 2. Power of 4. But n is equal to 3. Whether it is a power of 4? No. We cannot represent it as in the form of 4 power something value, some integer value, right? And n is equal to 32. 32 also cannot be represented by 4 power something value, right? So these are false. These are false condition, and this is the true condition, right? Now, how to approach this problem? Let me take first the example, maybe 64. Okay, 64. Divide by 4. What will be the quotient and remainder? Quotient will be 16. Remainder will be 0. Again divide by 4. 4 0. Again divided by 4. 1 0. Stop it. It is for the observation of 64. Now again, I just take 32 maybe. So 4. So it is 8 0. Fine. Again 4. It will be 2 0. Fine. Again 4. Cannot be done anything. So stop it. Fine. Now take 3. 4. We cannot do anything. Stop it. Now I can add a 0. Okay. Now listen carefully. Here all these values are 0 and end up with 1. Here also all the values are 0 and ended up with 2. Here, if we don't consider it, we are ended up with 3, right? This is my first observation. Now let me take another number like maybe 10, 4. If I am dividing 10 by 4, what will be my quotient? 2. What is my remainder? 2. Right? I will stop here. I cannot do anything, right? I will stop here. Now see, remainder is 2. Also quotient also 2. So I can say wherever we get a remainder which is not equal to 0, I can say it is false. Because it is not a power of 2, right? It's power of 4, right? Else I can say it is a true. This may approach. So this is the first approach. Fine. Now, what is the second approach? I can write it in the recursion. Fine. So this is the second approach. They two are same, but here I use recursion, there I don't use recursion, right? Now, what is the third approach? Whether I can optimize this solution by using the power of 2 approach. What power of 2 states? N and n minus 1 is equal to 0. If I am doing AND operation between a number and a previous number, if I get a 0 as output, then I can say a power of 2. So let me write a power of 2 up to 64. Then we can observe what is the observation for power of 4, right? Let me write it. See here. First of all, it will be 1, then 2, then 4, 8, 16, 32, then 64, right? Now, carefully observe here. Here, the 0 is power of 4. This 4 is power of 4. 16 is power of 4. 64 is power of 4. Right? But this is the power of 2 sequence. And see here, first number is power of 4, third number is power of 4, then again fifth number is a power of 4. So I can say in two elements, the first element is a power of 4, right? We are getting like this. Now let me write this in power of 2 so that you will clearly understand. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6. Yes. So I can get the observation like it is 0. It is power of 4. It is 2. It is power of 4. It is 4. It is power of 4. It is 6. It is power of 4. So I can say the values which are represented by 2 power something x, this x is even, then I can say it is power of 4. It is power of 4. So this can be my approach. Fine. But whether we can find this by using this formula? No, right? We can do this by using the logarithmic inbuilt function. But still, how to implement this bitwise operator formula? Let us see. So this is the power of 2 formula. If I think in a different way, whether in power of 4, if we divide that number by 3, what is my remainder? Just take 4 divided by 3, what is my remainder? 1. It is 1. Now 16 divided by 3, what is my remainder? 1. Right? Again. What is the next number? 64. 64 divided by 3 is equal to 1. Because 63 is the multiples of 3. So it is 1. Right? Again, 1 mod 3, it is 1. Right? So I can say whenever I am dividing by 3, I will get the remainder is 1 for power of 4. So I can say power of 4 should be a power of 2 also. Power of 4 should be power of 2, right? Power of 2. So I can say just put the power of 2 formula. This condition should be true. And what is the second condition? N mod 3 is equal to 1. So this is the second condition. Right? And the basic condition, always the n should be greater than 0, right? This is the third condition, because no negative numbers or 0 is a power of 4, right? So these are 3 conditions. So combine these all three conditions and do an AND operation between them. So 1 and 2 and 3, then I can say it is a power of 4. It's a power of 4. Right? Fine. So this is my third approach. And then fourth approach is I have told you already that 2 power x, and when this x is even, when this x is equal to even, I can say it is a power of 4, right? I have derived that in third approach, right? So I can say power of 4. Now I can say if log of some number n base 2 will give me an answer, and that answer should be even, then I can say it is a power of 4. It's a power of 4. Right? Take for example, I can give input as something 8. First we can try for 8, then 16, then 32, then for 64, right? Now what is the log of 8 base 2? What is log of 8 base 2? It is what? 3. So 3 mod 2, which is equal to 0. No. So it is false. Now 16, it is 4 mod 2 is equal to 0. So it is true, right? It is true. Now 32 will be 5 mod 2 is equal to 0. No. So it is not a power of 4. Now 6 mod 2 is equal to 0. Yes. So it is power of 2, right? Now we have successfully found out the formula for power of 4 from power of 2. And what is the condition when ceil value of log 2 n is equal to floor value of log 2n, right? Then only I want to do this stuff. Otherwise, I can say directly the number is not power of 2, then how come it is a power of 4? Then how can it is a power of 4? Right? So I can say like this. So I want to first check for this condition, then I want to proceed further to this statement, right? So I can simply write it like ceil of log n base 4 equal to floor of log n base 4. Then I can say true, else I can say false, right? This is my what? This is my fifth approach. Slightly modified from this approach. Right? So this is the another approach. Now at last, it is a basic approach. See here, I can generate all values, all possible values, and then check whether the number is in this possible values, right? See here, we want to read this constraint. This is a more important. See here, the number will be what? Greater than minus 2 power 31 and less than 2 power 31 minus 1, right? And we know no negative numbers can be power of 4. No negative numbers can be power of 4. So I can take what are my power of 4s? It is 4 power 0, first of all, 4 power 1, 4 power 2, 4 power 3, 4 power 4, going etc. so on, right? So this is my power of 4. And when to stop? Let us analyze this. So they have given the max range as 10 power 31. Let me assume it is 10 power 32. Always we want to round off, or we want to take the ceil value, right? So that 10 power 32. Now this 2 power 32. So this 2 power 32 can be written as 2 power 2 into 16, right? And this 2 power 2 can be written as 4 power 16. Fine. So I can say maximum possible value can be 4 power 16, not getting beyond 4 power 16, right? So my final values would be 4 power 16. So I want to generate totally 17 values of this power of 4s, and I want to store it in an array. In this array we have all the possible of power of 4s, and if they give x value, we want to check whether this x is in this array. If it is in this array, then I want to return true, else I want to return false. Clear? This is my sixth approach, right? Let us see the code. Let me comment this. See here, if n is less than or equal to 0, I will return false, right? We have already seen that no negative numbers can be a power of 4. While n mod 4 is equal to 0, I have told you that remainder remains what? 0, and n is equal to n divided by 4. I am constantly dividing n by 4, right? Then at last, if the quotient is equal to 1, I will say it's a power of 4. That's I have done here, right? See here at last the value should be 1, and all the remainders should be 0. That's why I have used that while loop in this way, right? Let me submit it. So this is the basic approach, right? Yes, it is submitted successfully. Now the second approach is a recursion approach, slightly modified from the basic approach, right? See here, def check of n. If n is less than or equal to 0, just return false. Else if n is equal to 1, if n is equal to 1, I can say return true, because let us see the body of the recursion, then we can come to the base case. See here, return n mod 4 is equal to 0. First of all, I want to check whether the remainder is 0. Then only I want to proceed with what? Dividing the number by 4. Then only I am proceeding with what? Dividing the number by 4. If constantly dividing the number by 4, and if I get the quotient as 1, I want to stop here, right? That's why I have used this base case. And I want to return true, right? right? So this is the recursion approach. I want to call this function. Let me submit it. If you know this recursion approach, it is an added advantage, right? You can also do this problem by using this recursion. And then this is a last approach I have told you, right? You want to generate all possible combinations. See here, I will generate all possible combinations. It is up to 17 or 16 combinations, and I want to check whether the given number is in this combination. If the given number is in this combination or in this possibility, then I will return true, right? So this is my last approach. Let me submit it. Yes, it is submitted successfully. Next approach. See here, I have told you, right? We want to check whether n is greater than 0, and also log of n for base 4 should be equal to that. I have told you that ceil value of log n base 4 should be equal to floor value of log n base 4, right? We can also do it like this, in this way also, right? We can also put, like, if the generator value should be whole number, right? If we are taking some x value and doing a logarithmic operation in base 4, then we have to get the whole number, that is an integer number. That's why if the answer is equal to integer of answer, then I can say return true, right? Let me submit it. And I also show you by using the ceil and floor function. Just wait. Here I used ceil, then here I will use floor function. Let me submit it to, let's see. Yes, it is successfully, right? We can do in two methods, right? Then another method is, I have already told you that we want to take a logarithmic of what, n base 2, then we want to mod with 2. That is, if the power is in even, then only I want to return what, true, right? So that's what I have used here. Fine, let me submit it. Yes, it is submitted successfully. Now at last, this is the bit manipulation. This is a bit manipulation technique where the power of 4 should be the power of 2, and also whenever I am dividing a power of 4 with 3, I will get 1 as a remainder, and the number should be also greater than 0. So that's why I have used here, right? Altogether, there's 3 conditions. Let me submit it. So this is the most efficient way to solve this problem, right? Yes, it is submitted successfully. Thank you.